Now we can talk about arcs and sectors. In the previous lesson, we said that arc measure, the number of degrees in an arc, was one way to talk about the size of an arc. As long as we are looking at two arcs in the same circle, arc measure is adequate to compare the size of two different arcs. If we start comparing arcs in different size circles, it becomes clear that arc measure alone is not sufficient. The two arcs have the same measure, 30 degrees, but they are not the same size in every way. Clearly, from C to D is a much larger distance than from A to B. So they have two different lengths, even though they have the same measure. How do we find the length of an arc? The length is called the arc length, and it is found by setting up a part-to-whole proportion. Remember that a proportion is an equation of the form fraction equals fraction. So we're going to have part over whole equals part over whole. One part over whole is going to be the arc length. The arc length is part of the circumference. So it's going to be the arc length over the circumference. The other part is going to be the arc measure, or the measure of the central angle. And that's part of 360 degrees, which is all the way around the circle. So it's going to be arc measure over 360 degrees. And so writing this out, we get this. And of course, we've just subbed in the formula for the circumference of a circle, 2 pi r. So that is a good proportion to know. And again, don't just memorize this. Make sure you understand why we're doing part to whole with both the lengths and with the angles. So for example, in this circle, 120 degrees is a third of 360, so arc AFB must be a third of the whole circumference. So the whole circumference, 2 pi r, is 48 pi. Well, a third of that would be 16 pi. Here's a relatively easy practice problem. Pause the video and work on this. Okay, if the length of arc CDE is 12, then find the area of the circle. Well, first of all, let's think about that. 72 over 360. We don't need a calculator for this. 72 is 2 times 36, and 360 is 10 times 36. Cancel the 36's. We just get 2 over 10, or 1/5. This is 1/5 of a circle. So the circumference would just be 5 times that arc. 5 of those arcs would make the circumference. So 5 times 12 pi, which is 60 pi. And of course, that has to equal 2 pi r. So if we solve that, divide by pi, divide by 2, we get the radius equals 30, just 30. Now we can find the area. Area equals pi r squared. Pi times 30 squared. 30 squared is 900. So the area is 900 pi. Just as we can divide the circumference into fractions, we can divide the whole area of the circle into fractions. So a slice of the circle like this is called a circular sector. And so a sector is like a slice of pizza. And we could even say that the arc length is like the crust of the pizza. So that circular sector has an area. We could find the area of the sector by setting up another part to whole proportion. So we're still going to have central angle over 360, but now we're going to have area of the sector over area of the whole circle, pi r squared. We equate the ratio of the areas to the ratio of the angles. So that's the formula for the area of a sector. And again, don't simply blindly memorize. Make sure you understand how we got this. So for example, in this circle, we know that 60 over 360 is 1/6. Area equals pi r squared, which is 18 times 18. I'm just going to leave it like that. If we divide that by 6, we get 3 times 18. 3 times 18 is 54. So the area of that shaded sector is 54 pi. Here's a hard practice problem. Pause the video and then we'll talk about this. Okay, we're told the diagram is not drawn to scale. We know the radius of the circle, it's 8. and we know the area of that sector. That sector has an area of 16 pi. And notice that we want the length of JLK. JLK is this arc all the way around the circle. All right. Well, because we know the radius, we can find the area. The area of the circle, pi r squared, is 64 pi. That's the area of the whole circle. So how much of that whole circle is this sector taking up? It's taking up a quarter of the circle. Well, that's interesting. That means that the central angle has to equal 90 degrees. We're told the diagram's not drawn to scale. It certainly is not. JOK is, in fact, a right angle. And so that sector is a quarter of the whole circle's area, and the arc length has to be a quarter of the circumference. Well, the circumference is 2 pi r, or 16 pi, a quarter of that. Well, the quarter, this part here, JK, that has a length of 4 pi, but we're not looking for that. We're looking for all the way around the circle, 3/4 of the circle. 3/4 of the circle is 12 pi. So we go back to the answers and choose answer choice C. In summary, we find arc length and area by setting up similar part-to-whole proportions. In both cases, we're setting up the proportion equal to a proportion of angles. So arc length is part of the circumference. It equals angle over 360. Area of a sector is part of the area of the circle, pi r squared, and that equals angle over 360.